Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 12.2, Problem 12. This is Section 12.2, Problem number 12. It says, find the equation of the line that is tangent to the function f of x equals 2x over x plus 3 at the point where x is 3. And there's a hint that goes with this. So actually in the homework, the hint isn't printed in number 12 because it shows up in number 11, the previous one. But as we do the solution, it's using this hint, which is when a line is tangent to a function, it touches the graph of the function at just one point, like this, and has the same slope as the graph of the function at that one point that it touches. So the straight line and the curved line have the same exact slope, or the same amount of tilt at that one point where they touch. And since the tangent line, the straight line is a tangent line, since it is a straight line, you use the formula y minus y1 equals m times x minus x1 to find the equation of that straight line, that tangent line. That's the hint. Our function is f of x equals 2x over x plus 3. And the question says, find the derivative of the line that is tangent to this function at the point where x is 3. And the little hint says that the tangent line is a straight line that touches the function at just one point and has the same slope as the graph that it touches at that one point. And it says when x is 3. And we're going to use the formula for a straight line, y minus y1 equals m times x minus x1, to find the equation of this tangent line. The tangent line is a straight line. This formula will tell us the equation of all straight lines, so that's what we're going to use. And if you remember how to use this, you plug in a number value for y1, number value for m, and a number value for x1, and the rest of it stays. The y stays, the parentheses stay, the x stays. We put in a number value for y1, for m, and for x1. Well, the x1 is given to us really in the statement of the question. It says it's 3. So this point is over 3, up something. So let's find that first. Up how much? Now to find that, we're going to put in a 3 for x in the f of x. Again, no prime to find the height. When we do the prime, what we're going to do is find the slope. So when we just put in the 3 in f of x, we're finding the height, the y value. So f of 3 equals 2 times x in the numerator becomes 2 times 3. And 3 plus 3 is what you get in the denominator. X plus 3, when you put in a 3 for x, becomes 3 plus 3. So the numerator, 2 times 3 is 6. The denominator, 3 plus 3, is also 6. And that will reduce to 1. That's the y value. So the point where they touch in one spot is over 3 up 1. Again, the 3 was given to us in the statement of the question. We figured out the 1 by plugging in the x of 3 into the function that's in the problem. So of the 3 things that need a number value, we have the number value for 2 of them. We have the number value for the y1 and for the x1. We have to just find it for the m, the slope. And we find that by finding the derivative. So the derivative of, let me write the function over here, f of x equals 2x over x plus 3. What you have to realize about this function to take the derivative is this function is a quotient. It has variables in both the numerator and the denominator, and I have no algebra trick to get the variable out of the denominator. I need to use the quotient rule. And the quotient rule is f prime of x equals vu prime minus uv prime over v squared. And the u and the v are from representing the top of the function as the u and the bottom of the function as the v. So let's figure out the v, the u prime, all the stuff we have to figure out to fill in this formula. So the first piece is v. No prime, just v, just x plus 3. Then the next piece is u prime. So u is the numerator of the function, which is 2x. U prime is the derivative of that 2x, which is just 2. Again, when you have just an x to the first power, the derivative is whatever the number in front of the x is, which is 2. That's why my u prime is 2. Now I'm at this part of the formula, the minus. Then that next part is u with no prime. Again, u is the numerator of the function. U with no prime is 2x. And at the end of the numerator of my quotient rule is v prime. So again, v is the denominator of x plus 3. V prime is the derivative of x plus 3, which will just be 1. Again, the x can be thought of as 1x to the first power. When you have an x to the first power, the derivative is just the number in front of the x, which is not written, but it's understood to be 1. The 3 on the end has no x with it, so its derivative is 0. Technically, it's a 1 plus 0, which is still 1. And then underneath, I have v squared. No prime, just v, but squared. So v, the denominator of my function, is x plus 3. And I'll do second power for squared. Now, that is my f prime of x, and I can start plugging in any number I want for x right now, but I can clean it up just a little bit at least. So f prime of x is x plus 3 times 2. Let's do the 2 times both the x and times the 3. 2 times x is 2x. 2 times 3 is 6. Then minus 2x times 1. Well, 2x times 1 is 2x. And again, it's minus 2x because of the minus in my quotient rule. And in the denominator, I can just let x plus 3 in the second power, in parentheses to the second power, stay the way it is. And on top, positive 2x, negative 2x. I have f prime of x equals 6 over x plus 3 in parentheses, where the parentheses are raised to the second power. That'll tell me the derivative or the slope for any value of x that I want. So this particular problem says find the value when x is 3. So that'll tell me the slope at that one point, that point that has an x value of 3. So f prime of 3 equals 6 over 3 plus 3 in parentheses second power. So 6 over 6 to the second power. 6 over 36, 6 to the second power, 6 times 6, which is 36. And I can reduce that to 1/6. That's the slope at that point that has an x value of 3. Again, because the line curves, at different points it have a different slope along the curve. I want the slope at the point where x is 3. So going back to my equation for a straight line, y minus y1 equals m times x minus x1. Again, I need a number value for the y1, the m, and the x1. And I have a number value for all of those now. So from before, I knew the y1 was 1. Again, we got that by putting the x of 3 into the f of x, and we got our y as 1. Equals m. We got that from taking the derivative and putting in a 3. We got 1/6. Then parenthesis x minus x1. The x1 is the x-coordinate of the point, which was given to us in the problem, is 3. So that's the equation of the line that's tangent to the function at that one point where x is 3. And if you wanted to, you can clean it up. This would be good for full credit. But if you like, you can put it y equals mx plus b form. Let's clear our parentheses first. 1/6 times x is 1/6 x. 1/6 times negative 3 is negative 3/6, which would reduce to minus 1/2. And to finally put it in y equals mx plus b form, the minus 1 on the left side of the equals will come over to the right side as a plus 1. Again, when you cross the equals, it'll go to opposite sign. So it's gone on the left. Y equals 1/6 x. Positive 1 negative a half is plus a half. Now that's even in y equals mx plus b form. That's the equation of the line that's tangent to that function, f of x equals 2x over x plus 3 at that one point where x is 3.